Hey everybody, welcome back. I must admit, I'm a little bit addicted to building combinators over futures. And the reason for that is that once we move from the world of regular types, T or trie of T, into the world of futures, we cannot use regular control flow anymore because everything becomes callback based. And hence, in order to do that, we need a lot of higher order functions to make our programming life easier. And in this lecture, these two lectures here, we're going to look at yet another little combinator on futures. And we're also going to have some fun. All right, so this is really just a fun lecture to show off how good we are as functional programmers. Okay, remember this code here where we read from memory and we use flat map and so on. Of course, we can write the same code using for comprehensions because futures are monads. They support all the constraints to use for comprehensions. So we can write the code as this: read a packet from memory, put it in packet, and then save the packet. You get a confirmation, and you yield a confirmation, and the result type is future of array of bytes. Now, the thing that we were trying to do is to make sending this packet resilient to failure. And we messed around with that. We defined even a new combinator. And what I want to do now is I want to define yet another combinator to deal with failure. And the combinator that I want to introduce is called retry. It's here on the slide. And retry takes two parameters in a curried way. So the first is the number of times that you want to retry a computation. And the second one is the future that, the computation that you want to perform. Okay, so retry number of times that block. And then you will return a future as soon as that block succeeds, or if it still fails after number of time tries, then you return the error message. Okay? Now here's a simple implementation of that. We can just use recursion. So if you have run out of number of times, you immediately fail. So you just return a future that represents failure with a new exception saying, sorry, I tried n times, didn't work. What do you do otherwise? Well, otherwise, you execute the block, and if the block fails, you fall back to the recursive call to number of times -1 with the same block. So this code, you have to admit, looks pretty nifty. It looks very elegant, but the downside is that it uses recursion. And some people say that recursion is the go-to of functional programming. And so they frown upon this where there's explicit recursion. And they say, oh, no, you have to use higher order functions that hide the recursion. So let's see what the consequences of that are. So let's do some macho programming, but we will do that after the break.